All right, let's continue now looking at polynomials. So here I've already written down a function or an equation. Wow. I thought that would help. Let me get this thing focused. All right. So now, let's determine the zeros of this, or we could say the x-intercept, same thing. And for this problem, we'll just ask for the factors. To determine these kinds of things, we're going to always have to factor. If we can't factor, we can't really answer these questions. So hopefully all of you remember how to factor. In this case, this is a trinomial, but I notice I have a greatest common factor. I have an x in all my terms, so the first thing I do is I have to factor out an x. So then inside the parentheses I have x squared minus 2x plus 1. And now I can try and factor this trinomial inside the parenthesis, which ends up being, I believe, x minus 2, x plus 1. Now when I factored this, in my head what I just did, I just found the factors, right? The factors are the two numbers I said that if I multiply them together, oh, this is incorrect actually. Whoops. Be careful with your factoring. Actually, the factors are minus 1 and minus 1, right? Because you multiply minus 1 times minus 1 equals 1, and you add minus 1 equals negative 2. So really it's this, of course, would simply write that as this. All right. But I found my mistake quickly. So what I did, in order to factor, I had to figure out my factors. So for this, the factors actually are minus 1 and minus 1, or I need to write it once. But also a factor here, we just talked about the last video how the factor there would also be 0. So there are two factors, minus 1, 0. And then for the zeros, I now look at this equation and I say what values of x would cause this whole expression equals 0. This first x, if that x is 0, the whole thing is 0. And then if x is 1, the parentheses will be 0, the whole thing is 0. So there are my zeros. All right, not too difficult. Now, let me tell you about something new that we've seen here that we need to talk about. You notice now we actually have a exponent of 2 on this parenthesis. And that brings up something else that we have to understand, and that's what they call the multiplicity. And the multiplicity is basically the exponent either on the parenthesis or on the variable. So here's what they like to say. For this, let me write it here, and for this factored equation, here's what they'll say sometimes. They'll say, first, our first factor is 0, and for that factor, the multiplicity, in other words, the exponent on the variable for the factor of 0 is just 1. Now, for here, my factor was negative 1. The multiplicity means what is the exponent the multiplicity is 2. If that confuses you, if I write it both as parentheses, when the factor is 0, the exponent on the parentheses is 1, multiplicity of 1. For my factor of -1, which gives me x minus 1 squared, multiplicity is 2. Let me just make up another function, and let's write down what the factors would be and what the multiplicities are. So anytime you have just an x by itself, you know that is a factor of 0. So therefore, for this one, factor 0, multiplicity 3. Because the exponent on the x is 3. For this parenthesis, what would the factor be? It's just a number here. What's the multiplicity of that one? It's just 1. Because there's really a 1 there. Then for our last parenthesis, the factor would be -2. And what's the multiplicity? In that case, the multiplicity is 2. Now here's what they like to do. So now, I've given you all this stuff, and here's the kind of problem they're going to give you. They're going to basically describe different facts about a function, and based upon everything they tell you, they want you to figure out what the actual function is. So for example, here's the problem we're going to do. They're going to say, find the function, and here's what they tell us. Find the function where you have, now in this case, sometimes they may give you the factors, and sometimes they may actually give you the zeros. It's just all according to what they want to do. Matter of fact, I'm looking through some problems, and I'm trying to see, for example, what kind of things they tell you. And let me look real quick, because they may do both. Here's an example where they give you 0, zeros, zeros. Actually, all the problems I'm looking at, a lot of times, they actually give you the zero. So let's do that. So I'll state this problem in terms of zeros. So you have a 0. First one is 0 equal to 0, the number 0. And for this one, you have a multiplicity of 1. But we have some other zeros. Remember, zeros are values of x that would cause a function or an equation equals 0. Let me give you the information, and then we'll work it out, and then hopefully it'll make sense when we're all done. Then they say there's another 0. In other words, when x equals 2, our function is all going to be 0. And for that one, the multiplicity is 2. And they have a third 0. Which is -3. And for that one, the multiplicity is 1. Then they say one more thing. Here's a point on the function. By that they mean 1/8. When we figure out our function, if we plug in 1 for x then the y or the f of x should be 8. So they give us a point, a solution to our equation or function. So based upon all this, they're saying come up with the function of the equation where all these things are true. All right. Well, when you have a 0 of 0, I know that means I have the variable x. Once again, what does 0 mean? 0 means the value that I plug in for x that will cause the whole equation to equal 0. A 0 of 0 means if I plug in 0 for x, this whole thing is 0. And the multiplicity is 1, so the exponent's 1. What happens if I have a 0 of 2? A 0 of 2 means I know that I now have this parenthesis. Because of 0 of 2 means if I set x equal to 2, that will cause the whole equation to equal 0. Well, that'll only happen if I have x minus 2, because I plug a 2 in for x, and 2 minus 2 is 0. Now for this one, it says, but the multiplicity is 2, which means the whole parenthesis gets squared. And finally, they say of 0 of negative 3, it's almost like you have to think backwards, because when they give me the 0, they're saying when I plug in x equals negative 3 into my equation, that's going to cause the whole equation to equal 0. Well, that's only going to occur if I have x plus 3 inside this parentheses. Because when I plug in a minus 3, this is 0, the whole thing is 0. And here the multiplicity is 1. So actually, based upon this information, I've come up with this part of the function. So once again, to review, when you have a 0 that equals 0, that causes you to just have x. When I have a 0 of 2, that causes me to have parentheses x minus 2. And since the multiplicity is 2, I have an exponent here of 2. If I have a 0 of minus 3, that causes me to have a parenthesis of x plus 3, and the multiplicity is 1. Once again, just to say it again, remember what zeros are. Zeros are the values of x that will cause this whole thing to be 0. Right? So if I look at this, if I didn't have this information, I gave this equation, said, what are the zeros of this function? You would say the zeros would be x equals 0, x equals 2, and x equals minus 3. Well, those are the zeros that they gave us. So based upon giving us the zeros and the multiplicity, we were able to create this function. But there's one last thing we haven't accounted for, and that's coefficients. Sometimes there's actually numbers also in front of our variables. There might be a number here. So what we normally do is, when I do all this stuff, I put an a in front, where an a is going to be my coefficient. And I actually need to figure out what number I should put in for a. So here's what I'm going to rewrite f of x as y. So here's my equation. Y equals ax times x minus 2 squared times x plus 3. Now really, if I can figure out what a equals, then I'm done. I've got the function. I've got the equation. How do I determine what a is? Well, you know what? When I go back up here, here's something they told me. that I haven't even used yet. And they said, here's a point on your function or on your line. And a point means when x is 1, y is 8. So what I can do, I can take that point and plug it into my function. And when I do, all the x's and the y's become numbers. And the only thing I'm left with is a. And I can actually solve for a and figure out what a equals. So in other words, by using this point, every place I have an x, I'm going to plug in a 1. Every place I have a y, I plug in 8. So this becomes 8 equals a times 1, 1 minus 2 squared, 1 plus 3. Right? So I'm just plugging in this point into the function. Every time I have an x, I put a 1 in. Every time I have a y, I put an 8 in. Now, if I simplify this, this is a. 1 minus 2 is negative 1. Negative 1 squared is just 1. 1 plus 3 is 4. So 8 equals 4a. I can solve for a, which is 2. And now I can say this is the function with the information they gave me. Here's the function that fits. And just to warn you, I think sometimes in the homework they may want you to give this answer as a polynomial. In other words, multiply it out. I'm not going to do it now, but basically, because it's sort of a pain, it's a lot of work. So if I break this up, in a sense, what they want you to do is to multiply out all these parentheses. It's sort of a pain, and you have to be careful, but sometimes that's what they want the answer to be. I'm not going to do that now because this is just sort of busy work for algebra. That's the kind of thing they want. So that's the kind of problems you're going to be given on the homework, on the quiz, probably on the test. Matter of fact, I have a note here to do another kind of problem. Let me look at it and see what it was that I was thinking of doing. Let me find it. All right. So let me write down. They've given me a function. Let me ask a bunch of questions. Here's the function. Looks like it's in factored form. That's nice. I appreciate that. So here's a function. Then they ask a bunch of questions. Now the first question is one that we haven't talked about yet. And this, it's part A, and they say basically what's the end behavior of the function? Like, what in the world does that mean? End behavior means what does your function equal when x equals infinity, or actually, I think in this case they just want positive numbers. So basically, let me just talk about when x is infinity. X equals infinity means a huge number. End behavior means it's almost like if we were to graph this thing, and here's x, 1, 2, 3. Where is infinity on the x-axis? It's way out here. even farther out than you can imagine. We would say it's way at the end or the edge of the graph. Well, that's why they call it end behavior. So they're saying what happens to your function when x is really big, way at the end of your graph. Now most of the time for polynomials, because I have x squared and x here and x here, if I plug in a huge number for x into here, like if I plug in 1,000,000, so 1,000,000 squared times 1,000,000 plus 5 times 1,000,000 plus 5, that's a huge number. And the bigger the number I put in, the bigger the function's going to be. Now sometimes we're going to see later on there are some functions where when x gets really big, the function doesn't just get bigger. Sometimes the function approaches a number and it just sort of gets stuck on a number like 0 or 1 or 5. That happens. But in this case, if I plug in a huge number for x, I get a huge answer for my function. So basically I say the end behavior now the thing is, another thing I have to sort of understand is if I were to multiply out let me just do it. It's easier just to do it than to try and explain it. When you're talking about end behavior, a lot of times, here's the one case where having the function factored doesn't really help you that much. When you're talking about end behavior, it's almost best if you multiply out all your parentheses. So let's actually do this down here. So let's first multiply x plus 5 times x plus 2. So a lot of you learned to FOIL. So if you FOIL this, I'm going to try and do it in my head and hopefully not make any mistakes. I think if you FOIL it, you get this. And now, to totally get rid of the parentheses, multiply everything by x squared. X to the 4th plus 7x to the 3rd plus 10x squared. Now, we're still talking about this idea of end behavior. What happens when x is a really big number? And there will be times also when we talk about maybe when x is a huge, big negative number. But for now, let's just talk about when x is a huge positive number. When you look at end behavior, here's what we do to try and estimate an answer. And I'm going to write it down and then show you. Keep only the leading term. In other words, if I had the time and I had my calculator, what have I got here? X to the 4th plus 7x cubed plus 10x squared. The key things are x to the 4th, then I've got plus x cubed plus x squared. Do you know what happens when you start plugging in really big numbers for x? Because this is x to the 4th, that means you multiply the number times itself 4 times. For this one, x cubed, you multiply the number by itself 3 times and 2 times. You know what happens? When you start putting in big numbers and you multiply that number by itself 4 times, that number gets to be unbelievably big. Now, even though x cubed is also a very big number, x to the 4th is so big, it even like dwarfs out and overshadows x cubed and x squared. And as we put in even bigger numbers for x to the 4th totally, x to the 3rd, x squared, these things become almost like nothing. This x to the 4th dominates. It becomes almost everything to the point where these other terms almost become insignificant. And that's why when we want to make an estimate of end behavior, once again, end behavior is when we put in huge numbers for x. So when I start putting in huge numbers for x, x to the fourth dominates, and the x cubed and x squared becomes almost like nothing. So what you do is, you basically, here's what I have initially. When I say keep only the leading term is the term with the largest exponent. And I just basically say, you know what? It's like I can just cancel those. When x gets really huge, these terms don't even matter anymore. So basically I can say my function, when x gets really huge, my function, the end behavior, is really just x to the fourth. So, all that to say, this very first question, f behaves like, that's how they phrase it, f behaves like, here they ask for y in the actual answer, which is same as f of x. Basically, I can say y equals x to the fourth. Let me make it clear. When x is huge, which means that's a way of saying when I'm looking at the end behavior. When I'm looking at end behavior when x is huge, basically the function or y is going to basically equal x to the fourth. All right, that was only part A. Now this kind of information, we're going to use it again in a little bit when we talk about some horizontal asymptotes. So what we've learned here is going to be helpful for stuff we do in a little bit. So we're going to leave in behavior for now. We're going to come to it again in a little bit. But for now, in behavior basically says you keep only the leading term, and that's what your function ends up being equal to. Now part B, let me rewrite our function so we can even see it on here when it starts asking me these questions. Part B, they say, they ask for x and y intercepts. Well, we've talked about that before, right? If you're given an equation or a function, how do you find the x and y intercepts? For x intercepts, you set y equal to 0. You know, we can think of f of x as y. So basically, and I solve, so when I solve this equation, x would either be 0. From here, x is minus 5. From here, x is negative 2. So there are my x-intercepts. Now for y-intercepts, what do we do with y-intercepts? We set x equal to 0. So 0 squared times 0 plus 5 times 0 plus 2. Multiply this out. Now this is interesting. In this question I'm looking at, which is from one of your homework problems, it says the x-intercept is or are, and it says type an integer or a fraction. So here, you know what? They're not wanting ordered pairs like before. They're just wanting these three numbers. And that's what I talked about earlier. Sometimes when they ask for intercepts, they just want the numbers. Sometimes they want the ordered pairs. Here, they just want the numbers. So here are my x-intercepts. Here's my y-intercept. All right. Part C. Let me rewrite the function so we can see it, because everything we're doing is based off that function. So here's the function we're working with again. Part C says what are the zeros, and for each zero, give the multiplicity. Well, it's interesting. We just, the question before, figured out the x-intercepts. X-intercepts and zeros are the same. Although if I look at this, once again, what are the zeros? The zeros are the values of x that would cause the whole function to equal 0. So the first 0 for this one, let's do them one at a time, because they say for each 0, they want to know the multiplicity. So for this x squared, when x is 0, it's going to cause this whole thing to be 0. What's the multiplicity? The exponent's 2. So when the 0 has a value of 0, the multiplicity equals 2. For this first parenthesis, what value of x would cause this parenthesis to be 0, which causes the whole thing to be 0? Well, minus 5. Now for the multiplicity, what's the exponent on this parenthesis? It's 1. And then there's one more parenthesis, so there's one more 0. When x is negative 2, that's going to cause the parenthesis to be 0. And what's the exponent on that parenthesis? It's 1. All right, that's not too bad. That was part C. Now here's another. They have some more questions in part C, but these are things we haven't covered yet. So let me talk about this now. The idea is, especially, you have to sort of visualize, sort of thinking about graphing, if we were ever to graph this function. Because what happens is, you know what, if I were to think about putting this, if I were to ever think about graphing this function, you know what I've determined so far? These zeros, which are actually the same thing as the x-intercepts, I can now go to a graph, and I can graph these points, because these points are like x-intercepts. Remember, x-intercepts are where the graph crosses the x-axis. So I know here's 0. I know my graph is going to go through that point right there. 0 is like an x-intercept. Let's think of this as intercepts. The 0 equals 0 is an x-intercept of 0. 0 minus 5 is like an x-intercept of minus 5. And it's right here. And then also I've got a 0 of negative 2, which is like another x-intercept. So actually my graph, if I were to try and draw this graph, is going to go through all three of these points. I don't know if it's going to do this, or it looks like it's going to have to really be like a crazy graph. But now here's the thing we're going to get at. One of two things can happen. When I actually try and draw the graph for these points, one of two things can happen. The graph can actually cross the axis, or in a minute you're going to see, we like to say it can touch the axis. In other words, my graph has to go through this point. To cross the axis says maybe my graph looks like this. It comes in here. I actually cross the axis. That's an example of what it means at this x-intercept to cross the axis. But at the same time, there's a second phenomena that could happen. Sometimes we say it will just touch the axis. So say, for instance, if this one maybe touching means it comes down and it goes through that point, but instead of crossing the axis, it just turns around and goes back up. This line never actually crosses the axis. It just touches it at that intercept, and then it goes back up where it came from. So this is an example of when the graph crosses the axis, and this is when it touches. Now the interesting thing is, based upon the information we've gathered so far, we can determine for each of these zeros, for each of these x-intercepts, we can determine what happens, whether it crosses. Now when it crosses, I mean, it could cross like this. It could go from down to up. But somehow it's going to cross the axis. And the way to determine whether crossing or touching is by we look at the multiplicity at each of these points. So at 0, multiplicity is 2. At -2, multiplicity was 1. At -5, multiplicity is 1. So what do these multiplicities tell us? Well, here's what it is. If the multiplicity is an even number, like 2 or maybe 4, anytime that multiplicity is an even number, at that point, it's just going to touch the axis and then go back in the same direction it came. And as it turns out, if at that point the multiplicity is an odd number, it crosses. So I can go up here and I can say, for the 0 of 0, the x-intercept of 0, it has a multiplicity of 2. Remember I got the multiplicity because that's the exponent. And therefore I can say at 2, it's going to simply touch the axes and go back. Now, I don't know, it could be like this. I mean, it could be like this. I don't know which one of these it is, but I know it's got to be one or the other. It only touches the axis and it goes back. Because that's what happens when your multiplicity is even number. It just touches it. Now at -5, the multiplicity is 1, which is an odd number, so I know at this point, this x-intercept, we're going to cross the axis. It may go like this, it may go like this. We don't know exactly what it does, but we know it crosses it and it keeps on going the same direction. That's because the multiplicity is 1. 1 is an odd number. When the multiplicity is an odd number, we know at that point it crosses the graph. And then for -2, oh, I did this wrong. 0, sorry, you were probably all confused. When the 0 is 0, it touches, so maybe it looks like this. Or it could be like this. And -5 and -2, since the multiplicities are both 1, so in this case, it's either going to cross like this or like this. So crosses, crosses, touch. And it's all based upon the multiplicity. Alright, I tried to warn you guys, there's just so much stuff in this section. Every time we turn around, there's some new principle, some new concept. So hopefully you're understanding all these, and as you work the homework problems, you'll begin to get a feel for this stuff and go from there. So then the last part of this problem, which I'm not going to do here, they give you a choice of 4 graphs and ask you to figure out which one is the graph. So I'll let you work that out on your own. I don't have time to do everything. So anyways, let's stop now. We covered a lot of material, and then we'll come back and talk about a few more things.